Thank you for interest in the lead contamination component of AquaHacking Challenge 2023. My name is Ryan Otter. I am a lead and contaminant expert. My background is in environmental science and environmental toxicology. I've been a professor for 16 years and also work in the data science space as well. The challenge for this part of the AquaHacking is how can we innovate and improve the sequestration and elimination of lead in the Great Lakes. So what we want to do is a background on lead and figure out what technologies could be utilized to improve the sequestration and elimination of this contaminant. So why is lead a concern? Lead is a concern within human health for multiple reasons and the impacts it has on multiple organ and tissue systems, in particular, brain function and kidney function. But this is not just a concern of human health of adults. Lead, in particular, is a major concern within young developing humans in particular. Brain development with lead contamination is an absolute major concern and has been for a long time and will be as lead continues to be an issue in our environment. But lead is not just a human health concern, it is also a fisheries and wildlife concern. Lead in our environment has been shown to impact reproduction in fish and their metabolism. But not just in the aquatic system, also the terrestrial system. So what we have here are two images of either raptors, the bald eagle on top, or a condor on the bottom. And what you actually see in X-ray here is lead contamination from a lead shot from a bullet that the bird has ingested and therefore is a source of lead for that bird going forward, causing deleterious effects. So let's expand this one step further, not just into why lead is a concern, but what are the major sources of lead in our environment. For humans, the most common source of lead is our drinking water. And this comes from lead pipes, faucets, and plumbing fixtures. In particular, when these pipes erode, then the lead that is used in their construction pulls away from the material and gets brought into the water system. This can be from low pH, so high acidic environments. It can be from large volumes and age of pipes. But again, not just human drinking water is the concern. So environmental concerns for lead sources also come from batteries, which are very efficient and used very commonly, but can lead to lead contamination in the environment. Lead smelting, either by itself or in combination with other metals, leads to environmental sources of lead. And what I brought up just a moment ago is being lead shot. So if we just play this out real quick, you have a hunter that has shot an animal. When that animal dies, assuming that the hunter does not take the whole organism with them, then that becomes food for scavengers within the wildlife environment. And when they're consuming meat, they're also consuming the lead shot that is in that organism, therefore source of lead. Now, if we think about what levels of lead cause problems, the goal, of course, would be zero because there is no advantage to having lead within organisms. But we also luckily know through toxicological studies that there are threshold levels of what kind of the level of concern really should be. So here's an example of what the Center for Disease Control puts out for human children. Above this threshold level is a concern. Below is relatively safe. The FDA, the Food and Drug Administration, sets similar type levels for what we consume through food and drink. And the Environmental Protection Agency sets thresholds for our environment, including air, soil, dust, and water. The actual concentrations here are not the important point. The important point to take away is that there are threshold levels that we can meet. So we actually know what success is when we're trying to eliminate or sequester lead from contaminated waterways. We're trying to get below these levels. All right, let's talk about solutions, both traditional solutions and emerging solutions that have been used in lead projects in the past. Three major traditional solutions. The first one is filtration using carbon. It's a pretty simple idea where we take pretty much dirty water that contains lead and pass it through a carbon filter under the premise that lead wants to be bound to carbon more than it wants to be by itself. So as you're passing through the filter, lead will preferentially choose to be on carbon, therefore removing itself out of the aquatic solution and now filtered out of the waterway. Activated carbon filtration. There's also RO, or reverse osmosis, which is now using a selectively permeable membrane or semi-permeable membrane, where we can design these so it will take lead out when you put high pressure untreated water through it. In other words, you can build the membrane to only let through the things we want and stop the things we don't, right? This is the same thing we do with salt water to try to turn it into fresh drinking water. We just use a different semi-permeable membrane when we're using it for lead. It's a kind of high cost because it costs a lot of power, energy, to create that kind of pressure. Another traditional solution, again, high cost and high energy, is something called distillation, where here we put untreated water in that round bottom flask you see on the left of the image, and we basically boil water to turn it into steam, cool it down the cooling device, and now the water comes back into water droplets. The key to this is that water will evaporate, but the lead will not evaporate from the round bottom flask. And so when we turn it back into water droplets, it's pure water without lead being part of it. In emerging technologies, we use nanotechnology, similar to the carbon filtration we looked at before, except now we are using larger surface area to volume products. In other words, real small things, nanotechnology, to adhere more lead than we could in kind of traditional activated carbon. Same idea, just kind of a different type of filter. And then last is something called electrocoagulation. This is where we're applying electric current into water using electrodes, and that current will allow the environment for pollutants like lead to either float to the top or sink to the bottom, where we can then remove them and clean the water that it started from. So what are the key takeaways here? One, lead has negative effects across really the environment and human health. And despite the environmental preventive actions that have occurred, lead will be a problem in the Great Lakes for quite a while. So this is a problem really worth addressing because it is not near the end of being solved. And last, we need more minds thinking about how to advance technologies to address the lead problem. So what can you do? Well, can you think of solutions that are either modifying old ones or creating new ones to address the lead contamination issue, knowing that we have levels that we're trying to get to? If you need more information, I've included some links here across the Center for Disease Control, EPA, and FDA if you want to dive into this further. Thanks for the time and attention, and I'm glad you're considering lead contamination for AquaHacking 2023-24.